Alright, I need you to hold on to your hats because in Lesson 54 we have to cover a lot of material. We're going to cover ratios, proportions, and P's and Q's. So first of all, this is how you spell ratio. And then proportion looks like this. And these are actually very helpful concepts. We're also going to cover P's and Q's and P's and Q's. I use ratios and proportions a lot, especially in cooking or in solving everyday problems. So I hope this is useful for you. Alright, so ratios can be written as a fraction. Let's say 3/4. Let's say we're talking about brown sugar. Let's say you need 3 tablespoons of brown sugar for every 4 tablespoons of butter. Maybe you're making cinnamon rolls and you need to make a filling. So this might be your ratio. For every 3 tablespoons, I forgot to write tablespoons, of brown sugar, you need 4 tablespoons of butter. But let's say that you had 3 cups of brown sugar, and you need to know, well, if I already poured 3 cups of brown sugar in my bowl, how much butter should I put into my bowl? Well, if you understand ratios, you'll think, well, if when I had 3 tablespoons of brown sugar, I added 4 tablespoons of butter, it makes sense if I have 3 cups of brown sugar, I should add 4 cups of butter. So do you see how the ratio stays the same even if the units change? Now let's think of a slightly harder problem. Let's say that I had 15 tablespoons of brown sugar. And I need to know, well, how many tablespoons of butter do I need? And this is where it gets a little harder. Let's go ahead and write the first ratio a little closer. So if we had a ratio of 3 tablespoons of brown sugar for every 4 tablespoons of butter, if that was our original ratio, how much butter would we need if we had 15 tablespoons? Well, notice that to get from 3 to 15, we multiplied by 5, right? 3 times 5 is 15. So we would do the same thing to the denominator. 4 times 5 is 20. So if we had 15 tablespoons of brown sugar, we should add 20 tablespoons of butter. So that's what a ratio is. It's a relation excuse me, it's a relationship between 2 numbers, and we can actually grow this to any size. Let's say we had 1,500 tablespoons of brown sugar. Well, we would have 2,000 tablespoons of butter, and hopefully our recipe would still work. So that's why I said this kind of information is very useful, not just for math, but especially with baking, cooking, and a lot of other everyday problems that you might solve. So that's what a ratio is. The last thing I want to talk about, the second thing I want to talk about is proportions. You might see a problem like this. (20/15) equals 4 something. This would be a proportion. And there can be, well, first of all, let me show you a true proportion and a false proportion. So let's say you had 1/2 and 5/5. So is this a true proportion? Is 1/2 the same thing? Does it equal 5/10? Well, if you think of it, 5/10 can be reduced to 1/2. So, of course, 1/2 equals 1/2. And this would be a true proportion. But you could also have fake proportion. Let's say you had 1/2 equals 7/10. Well, we know that 7/10 is not equal to 1/2. So this would be a false proportion. So that's what a proportion is. It's 2 fractions or 2 ratios being compared to each other. Now let's go ahead and look at a conditional proportion. That's where you have 2 fractions being compared to each other with this equal sign, but you don't know if it's true or false because you don't know what goes here. How do you solve for x when you have 2 fractions connected by an equal sign? Well, hopefully you've heard of this before. What you do is you take the diagonal number, so 15 times 4, which equals 60, and then you divide it by the remaining number. So what's 60 divided by 20? Well, 60 divided by 20 is 3, so x would equal 3. So now let's go ahead and look at this. Is 20 over 15 the same thing as 4 over 3? Well, let's simplify the left side. 20 and 15 can both be divided by 5. 20 divided by 5 is 4. 15 divided by 5 is 3. Right, so now we have 4/3 equals 4/3. So 4/3 equals 4/3, and this would be a true proportion. Alright, like I said, it's going to be a long lesson. The last thing we need to do is learn how to solve problems that say things like this. Let's say you had x with an exponent of y, and then you're told, well, x equals 4, y equals 3. And like, can you solve this? Well, it's kind of like a code. All you need to do is rewrite this with, instead of x, write a 4. Instead of y, write a 3. 4 cubed equals 64. So 64 would be your answer. Now you might also see a problem like this. And you might be told, well, p equals 3, q equals, let's say, 8. So then all you need to do is rewrite it. Instead of q, write an 8. Instead of p, write a 3. What's the cube root of 8? What times what equals 8? That would be a 2. So that's all you'd have to do for those equations. They might look a little scary, but just think of it like a code. Wherever there's a p, write a 3. Wherever there's a q, write an 8. Okay, so this has been Lesson 54 on ratios, proportions, and p's and q's. Let me know if you have any questions, and if something was a little confusing, don't be afraid to watch us again. Alright, see you in the next lesson.